So, ladies and gentlemen, please allow me to switch to English. We have now a session which I very much like each year in the vgbe Congress. We are going to present the awards for innovation. Every year since 1981, we announce these awards for outstanding achievements of young engineers, young professionals in the fields of electricity production, storage, heat production. It's my great pleasure to invite Mr. Lukas Koltermann to join me on stage. I hope he's here. Yes, please. For the first innovation award, unfortunately, I have to say that our second, Lucas. Unfortunately, I have to say that our second winner, Mr. Marius Neuwirth, had a death case in his family, and he's unfortunately unable to join today. I will take the opportunity to introduce his innovative work later on his behalf, and he will have the chance to present himself and the work and his work in our vgbe Congress 2026. I think we all understand the critical importance of this award and the supporting of young talent, especially in light of demographic shifts and the increasing competition for skilled professionals in the labor market. Supporting and investing in the next generation, as we do through initiatives like the vgbe Innovation Award, is not just a responsibility, but a strategic investment that will undoubtedly yield significant returns for our industry in the years to come. Today, it's my great pleasure to announce the 45th presentation of the vgbe Innovation Award, which is this year once again honors two outstanding winners. Now I would like to honor Mr. Lukas Koltermann with the vgbe Innovation Award 2025. Mr. Lukas Koltermann started his career with a dual study program in electrical engineering at Cologne University of Applied Sciences in cooperation with Infraserv GmbH in Hürth. He then continued with a master's degree in electrical and information technology at the Technical University of Munich. Today, he works as a research assistant at the Institute for Power Converter Technology and Electric Drives at the RWTH Aachen University. The vgbe Innovation Award 2025 in the category Application Oriented is awarded to Mr. Lukas Koltermann for his work on the modular multi-megawatt, multi-technology, medium voltage battery storage system. His research has provided valuable insights into status analysis, reaction speed, efficiency, and energy management, making an important contribution to power and heat generation. Congratulations, Mr. Koltermann. I'm very pleased to hand over this to you, this award. This award is accompanied with a prize of 5,000 euros, which we are going to transfer by bank. So, thank you very much and congratulations again. Okay. Letters in the face. Numbers in the face are better, or what?
That's better.
Okay. Thank you. With respect to the interesting contents of this topic, Mr. Koltermann will present briefly his work here today.
Yeah, thank you for the kind introduction. And yeah, it's a great honor for me to receive the Innovation Award today. Thank you for this recognition of my work. So as you can see, the title of my dissertation is in German because it is written in German, but it would translate to analysis and optimization of the reliability and efficiency of a hybrid battery storage systems using the example of M5. So long title, in short, it's about stationary battery storage systems, and everything around it. And you may ask, what is M5-Bud? What is the example? M5-Bud is our own battery storage system at the Institute, and maybe you can go to the next part. It's the short form of Modular Multi-Megawatt Multi-Technology Medium Voltage Battery Storage System. So yeah, to keep it simple, I'll stick to M5-Bud. And here you can see an icon of M5-Bud. It features 6 megawatt and 7.5 megawatt hours in 5 different battery technologies, and it is ready for autonomous operation for frequency containment reserve, automatic frequency restoration reserve, and intraday trading on the intraday continuous market. And of course, as university, we use M5-Bud for battery testing and the development of the energy management system. To give you a bit more overview over my dissertation, please next click. I worked in the field of usable energy and to identify the usable energy and capacity of battery units. This comes along with the identification of common errors, but also identifying the battery aging and the state of balancing, which can be a major issue that different battery cells drift apart over time, and yeah, this has to be covered. Alongside usable energy, I went into the field of the reaction speed, which is super important for future applications, and in the case of M5-Bud, yeah, for maybe necessary upgrades in the future to serve future applications like synthetic inertia. Please, the next 2 clicks. And I dived into efficiency analysis and different operation parts, like the frequency containment reserve, which is almost all the time part load, and we reach a round-trip efficiency of 78% with our battery storage system, which is kind of a standard in the market. In spot market trading or intraday trading, we can reach up to 85% round-trip efficiency, and in our reference test, we measured 88% round-trip efficiency. Next to this analysis, I covered the field of energy management system. Please, next click. In terms of further development and programming the energy management system. Of course, I implemented it and tested the system at M5-Bud with my objective of efficiency and battery aging, so reduced battery aging and increased efficiency. Next slide, please. So what is the energy management system about? It's about field and external communication to partners, a monitoring of the batteries, and data aggregation of different battery units because we have a hybrid battery storage system. Then it's about the SOC management and power calculation, and the big part of my dissertation is the power distribution algorithm. So what does the power distribution do? Please next click. We have a set point we got to deliver power at the grid node, at the grid connection point. Of course, we measure the current output of the battery storage, and then the power distribution algorithm has to decide which battery unit is the best one to serve this target. So we have then kind of settings for SOC ranges for individual battery units where they age less. We have different power levels as a setting which battery we want to prefer, and then the algorithm calculates the best battery unit and sends set points out to every battery unit and every inverter, and so it's an asymmetric use of the different battery units. This gives some advantages. Please next click. So it reduces the inverter switching, it increases the overall round-trip efficiency, it reduces the battery aging, and improves for M5-Bud the reliability. All pros are what improved our operation in the last years. So this brings me to an end. Please next slide. If you want to find out more about M5-Bud, you can scan the QR code in the middle or visit m5bud.icea.rwth-aachen.de, and you will find the project and a live feed what the battery storage is in this second doing. And if you want to find out more about my dissertation or read it, you can scan the right QR code on this slide. So then I'd like to say thank you. And if you have any questions, I will round the Congress.
Thank you very much, Mr. Koltermann. As you said, you will be available also during the breaks. If there is some question, then please feel free to address it directly to Mr. Koltermann. Now, even from afar, I would like to honor Mr. Marius Neuwirth with the vgbe Innovation Award 2025. Mr. Marius Neuwirth pursued his studies in chemical and process engineering at the Karlsruhe University of Technology and is currently a research assistant at the Fraunhofer Institute for Systems and Innovation Research in Karlsruhe. In May of this year, he successfully completed his doctoral studies at the Technical University in Vienna in the Institute for Thermodynamics and Energy Engineering under the supervision of Professor Dr. Techner René Hoffmann, and he earned here his PhD degree. The award that he earned today recognizes his exceptional work in developing a dynamic, site-specific diffusion model to simulate the transition of energy-intensive industrial sites across Europe toward low-carbon technologies. His research focuses on critical sectors such as steel, cement, and chemicals, industries that are among the largest consumers of electricity and process heat and play a vital role in the energy transition. As mentioned earlier, Mr. Neuwirth will have the chance to present his work at the vgbe Congress 2026 in Berlin. Now, I would like to invite to the stage Mr. Tuncay Ertugrul and Mr. Denis Gotic for the presentation of the Quality Award. Quality is a fundamental issue in our business and the operation of energy plants. It is embedded in every phase of each project, from planning, how are you doing, from planning to operation. Quality ensures a successful, safe, and economic plant operation, even when the plant is no longer in service. Recognizing its importance, vgbe introduced the Quality Award in 2006. It was a time when several quality issues in new build projects arose, and we wanted to highlight the commercial significance of quality in our industry and to honor partner companies that have demonstrated exceptional standards in their deliveries and services. It's now my pleasure to present the vgbe Quality Award 2025. We have 4 winners and 1 who is going to get the award. The first one, I start with the 4th place. It is the Klima Automatisierungs GmbH for their project development of various automation solutions for several hydropower plants. The 3rd place is the Norbert Braun Industrie-Service GmbH for their project decommissioning of the reactor pressure vessels and its internals at the Gundremmingen nuclear power plant. The 2nd place goes to Socotec Deutschland GmbH for their project EnBW Fuel Switch project in Heilbronn, a project that, from my personal perspective, has been a truly remarkable success. And now, ladies and gentlemen, it's my honor to announce the winner of the vgbe Quality Award 2025, and the 1st place. It goes to GNS, Gesellschaft für Nuklear-Service MBH, presented by Mr. Tuncay Ertugrul, and Höfer and Bechtel, GmbH, presented by Mr. Denis Gotic, represented by Mr. Denis Gotic. Our vgbe member company, Preußen Elektra, entrusted the consortium of GNS and Höfer and Bechtel with the task of dismantling and packaging the reactor pressure vessel in compliance with the stringent requirements and regulations for final disposal at Schacht Konrad. This project is part of a fleet-wide program to dismantle the reactor pressure vessels across all nuclear power plants owned by Preußen Elektra. The Grafenrheinfeld plant was the 2nd in line, following the pilot project at the Unterweser plant. The dismantling process was a remarkable technical achievement, and the companies of these 2 gentlemen showed an outstanding performance during the execution of this job. Congratulations, Mr. Ertugrul and Mr. Gotic, on this outstanding achievement.
Thank you very much.
Wish you also all the best and good projects in the future. So this goes with you also. We can hold it here, and then we go again. Should I help you with this? Thank you. If you would like to say a few words, you are very welcome.
So, thank you very much, Mr. Stamatelopoulos, for having us in the introduction. Ladies and gentlemen, we stand here today as representatives for the many, many colleagues who have worked very hard on this project with deep gratitude. Receiving the vgbe Quality Award is not only an honor for us and our companies, it's above all a recognition of a great teamwork between our companies. We accept this award with pride and would like to thank the vgbe and the award committee for the valuable work they do in promoting and highlighting quality and innovation in our industry. A very special thanks goes out to our client Preußen Elektra and the Grafenrheinfeld nuclear power plant for the trust placed in us, the appreciation of our work, and the spirit of partnership throughout this whole project. So next we will briefly describe you what our project was about. Unfortunately, we don't have any nice slides here for you, but I will do it in words. Our companies have completed this project as partners. GNS is a leading company in the nuclear industry for cast development and nuclear waste management, and Höfer and Bechtel as a specialist in special purpose machine construction and tool development, particularly for the dismantling of nuclear power plants. The project involved the dismantling and packaging of the reactor pressure vessel of the Grafenrheinfeld nuclear power plant, and as you said, is a part of a project program comprising a total of 6 nuclear power plants of Preußen Elektra. The reactor pressure vessel, or short the RPV, is the heart of a nuclear power plant where nuclear fission and by that the heat generation takes place. And since the activated material of the RPV cannot be recycled, the approximately 500-ton RPV had to be lifted out of its installed position, cut into smaller pieces and packaged in so-called Konrad containers for final disposal. All of this was carried out under strict radiation protection and occupational safety conditions by using remote handling technology. What made this project outstanding was the soaring performance of the newly developed technology, which my colleague Denis Gotic will explain you in more detail. So thank you very much, everyone, and have a nice Congress.
Thank you.
Thank you, Mr. Ertugrul. Ladies and gentlemen, I would like to briefly present you a project on the cold dismantling of reactor pressure vessels, domes, and heads. Unlike usual hot cutting technology with torches, we used cold cutting methods which contain advantages and also challenges. At the Unterweser project, we use wire saws for dismantling the reactor dome and head. This dismantling procedure with the wire saws was costly and time-consuming, but we learned a lot from this experience. This approach improved, At the next project at Grafenrheinfeld, we switched completely to the newly developed large band saw system called the Beast. This approach improved safety, reduced the radiation exposure, and saved time and costs. For example, we saved more than 26,000 working hours on site and around 29 weeks of project time. The lessons learned approach was successfully applied. This dismantling method is a reference for the next projects. Thank you, ProSyn-Electra team, for your trust, flexibility, and massive support at this project. My thanks also go to everyone involved, and especially to vgbe Award Committee for recognizing our team performance. Thank you for your attention.
Thank you very much for this brief presentation of your very significant work. I encourage you to place a detailed article in our journal, and I am sure that you will find many interested readers in your work. Now, before concluding, let me draw your attention to our third award. This is the Safety Award, which we are going to present next year. As you know, we follow an alternate mode, 1 year quality award, 1 year safety award. But I want to remind all of us that safety is the basis of our business, and it is very important. With this, I hand over to Oliver.